You're listening to Pushing the Envelope, Life at the Cutting Edge of Customs Innovation. I'm Tom Muller with the Cross-Border Research Association. On this show, we explore the frontiers of customs creativity in conversations with customs and logistics experts, technology innovators, research scientists, and other leaders in the field. Industry insiders call this show the Pencast because it's part of PenCP, a network for boosting customs innovation funded by the European Union under the Horizon 2020 program. Today, I'm speaking with the CEO of GScan, an Estonia-based company that is producing vehicle and cargo scanning technology using recent developments in atmospheric ray tomography, ART. And it's an honor to be speaking with CEO Marek Helm of GScan. Nice to have you on the show, Marek.
For having me today.
Thank you for joining me. And it's first of all, congratulations on winning the PenCP Innovation Prize in May. That's a major achievement.
Thank you so much. Every attention to the new technology helps us to push it forward. Thanks a lot from our side also.
Well, it sounds like these are very interesting times for GScan and for you personally. Could you tell a little bit about what your background is and how you came to GScan?
So, good question. I have done many things in my career. Actually, I started as a customs officer at the border in 1995, so 20 years in customs, and then climbed up in tenure of the customs and taxation, and ended up as a Director General of Estonian Tax and Customs. And then I was running the authority till 2016. And then I moved to the private sector. The 5-6 years I spent my time in the Middle East, running the IT company there, and then helping to create e-government solutions in tax and customs area. And then recently, 1 year ago, I moved back to Estonia and got the offer from GScan. And now I'm the startup. So I'm doing something which is really, really exciting. It doesn't allow me to sleep properly because of this excitement. But yes, we are inventing something which might be in fact or impact to the future.
That's a great combination of skills and background, and obviously now you can bring 360 degrees of experience to the problems that GScan is trying to solve. Why is it a particularly exciting time?
No, because the technology is new and it hasn't been in use in past decades. And then same time, as you rightly mentioned, that I have bought many scanners for Estonian customs, and then these are based on X-rays or gamma rays, and everyone knows how they are used and how they are working. And now with GScan, we try to complement this way of doing the customs operations. Using, as you mentioned in the beginning, that using not the artificial radiation, but using something comes from the space, and how to detect these muons. They call these physical particles, the small particles. How to detect these smart guys, and how to create the valuable information over potential clients like customs authorities or security office.
And it sounds like, from what I've read, muons are the ideal sort of test scanning or particle to use for detection, because they're harmless. They penetrate deeply into almost every material, and therefore they can be used with proper computer processing power. They can be used with immense effectiveness in scanning.
Yeah, that's correct to say. On top of that, if I compare these technologies, I mean the X-ray or muon tomography, then the X-ray or traditional X-rays, they are measuring the density of the materials. Everybody knows that we are crossing the borders, or at the airport we see images of our suitcases, But this muon tomography, as you rightly mentioned, with the high penetration capabilities, what we are doing, we are able to measure chemical composition of the materials, and this is a totally different game. That you can differ from the container. Let's say the container with the bananas. It's a huge headache in our ports in Europe. You can hide cocaine in that container, and it's hardly noticeable. You cannot detect very effectively with X-ray solutions, but you cannot escape from the detection of the chemical composition of the materials. That's a totally different game.
I see. So the density of bananas and cocaine is similar, so X-rays might miss it, but the actual chemical composition of bananas and cocaine are clearly quite different. So
that said also that our technology is automized. It's not like manual. In X-rays, you need operators, and you need the people working in the shifts, and then it might happen that end of the shift. I have been in customs that there is a different skills of among the operators. That some of them are very smart, but some of them needs to be trained. And based on this automation, what we have in our technology, artificial intelligence and machine learning, we can train our software and then technology to detect these materials. So it's not about the imaging; it's about the real detection of the chemical composition automatically. Saying that yes, no one sitting behind the computer and then trying to see with their own eyes, but you'll get the automatic alert that in that luggage or in that container there is more than bananas. It has the something else.
I see. And I know that you're not a physicist, and even if you were, I wouldn't be able to understand what you said. But the core technology, if I'm correct, is using scattering of atmospheric ray flux that includes muons, electrons, positrons, and some neutrons as they pass through objects to detect and identify contents of cargo. Is that right?
Sounds correct. Again, sounds correct, Tom. And then how we are doing it? Basically, we are producing these so-called detector hodoscopes, and then the main materials or main approach we are using is that we are using the sensitive fiber optic cables. And these cables have special materials. And if the muons come from the space, they give some light effect. And this light effect captured by the certain setup of the electronics and translated to the information. So how muons going through the different materials, it keeps or it stays the space, or it gives the special trajectory. And based on this trajectory, capturing this information, we are able to say this is the water, this is the alcohol, or this is the banana, this is the cocaine.
I see. Fascinating. And I will be posting, with your help, some illustrative slides on a separate blog, so that people who are listening to this podcast will be able also to see some explanatory slides. But this is clearly very cutting edge material. Cutting edge technology. It sounds like you already have available now the muon flux infra. Is that right? The smallest of your units?
Yes, we signed our first commercial contract actually last December, and then it's a good story behind that contract. That 30 years ago in Estonia, when Russian military left, they used to have the submarine nuclear base training center on the shore. And before they left, they put all the nuclear waste into these submarines, locating on the shore, and it's 30 kilometers from Tallinn, and covered with concrete. So that is like two massive objects with the diameter of the one submarine is 9 meters. So fully concrete object, they're ferro concrete. And now the government of Estonia, they want to clean the area there. But you cannot go inside randomly because you don't know what is the material and where. So based on with the infra detector hodoscopes, which we are already using, that we are putting these hodoscopes under these large objects, and then we are creating 3D model of these two submarines to help the government to bury it down properly, and no one will get hurt during that process. That said, there are more opportunities to use this. That in the entire world, most mankind developed or built materials is ferroconcrete. Houses, buildings, water dams, and these large infra objects getting older and older. Some of them are more than 100 years old. And you don't know what is the shape of these, the bridges. And then people have heard that bridges time to time is collapsing. And basically this civil engineering world, they don't have solutions how to do the estimations of how many years left. And then another business domain based compared to this security and the customs, we have this so-called non-destructive testing solutions, and then already doing first projects.
I see. Well, it's what you mentioned about concrete and civil engineering. I don't know if you heard, but 4 years ago, a major bridge collapsed in Genoa, near where I live. It was a major tragedy. And since then, the Italian government has been trying to scan or trying to figure out what the state is of their reinforced concrete bridges across the country. A major problem. How would Gscan technology allow you to do that?
So basically, we use these photoscopes putting under these or next to these large objects, let's say bridge, because this natural radiation is not like strong. It's like a natural, and then we need time to capture this data. So it might be that if we want to have this like a very sharp resolution, how much metal left in the concrete. So we might measure this 3-4 weeks, keeping this detector layer, capturing the data. But after that, we are able to say that what is the condition, that basically what is the amount of metal still keeping this bridge together, and then basically helping the governments to manage their backlog to maintain the bridges. So we have already like a first pilot project almost ongoing with the national highways in UK. In UK, they have 1,200 bridges needs to be evaluated. So, and then 300 of them are critical. So, and then we are doing now pilot measurement testing with these guys there. And then if they like the technology, there is a way forward. Go to US, how many objects they have there. So it's like it's booming. So I'm very excited that to produce and then help these type of things.
Incredible. I mean, I can see why you're not sleeping. That's just one business line. I'm thinking that, the major infrastructure projects in the US, we've already talked about Italy. I mean, every Western European country at this point probably needs, to reassess things that were built around the end of World War II onwards. And
I was told Ukraine. Sorry to interrupt you, Dom, but in Ukraine they have 17,000 bridges.
Oh my word!
And not only connected with the war, but 8,000 of them are not on the standard, not meeting on the standard. So you don't have the exact money right away for all of them. So that's why we say, or you can take the Turkish earthquake. So you can use this technology to measure the quality control of if they're building the new bridges or the new ferroconcrete objects. So endless. You can go with the insurance companies that you want to insure something that what is the quality of that. Up to the medical. Also, that's like a lot of R&D still needs to be done, but X-rays are also used in medical. You can measure the your bone composition or how much water do you have in your lungs in the future. So it's like all back to the customs that how to measure the quantity of the certain goods, the very fast and then sharp way, not just like weighting them or trusting what is on the paper, but you can just measure through the detection data. These containers includes 25 tons of banana. That's it, nothing else.
Right. Incredible. And yeah, the fact that it's harmless, all of these things that you're talking about can be done while people are around without interfering with or creating safety hazards.
Yeah. Only how to say the paradigm we need to change, that it's not the photo shooting. It's not a photo shooting because the radiation is not artificial. It might take time. So, but this is compared to accuracy is a totally different level. So it's like in my previous background working in the customs, I might say that all the X-ray controls are more or less preventive. So, but the capabilities to do the X-rays, it takes time. You need to take the track to lorry to try to the certain control hall, clean the area. Then you have operators analyzing the picture. So it's valuable time you can use differently if you have these roofs entering the customs checkpoints, and because it's harmless, you can put detector layers up top to the roof or under the roof, and same time you are doing your paperwork or customs remit, you just scanning harmlessly, just scanning. This is the future. Don't believe me, this is the future.
This is exciting. You're getting me excited about it now. Is it true that your Gscan detector panels are scalable, something like Lego blocks, so you can build them out in any configuration?
So basically, this is a modular-based solution. If you want to make one room as a detector room to clean make sure that you are like very VIP sitting somewhere, and then you want to make sure that in this building you don't have any explosives. So basically, you put these detector lasers behind the wall, and that's it. So you can put it as much as possible. We have the project called Silent Border. So it's like, and we need to be ready with the first large-scale scanner by 2025. So everyone can Google Silent Border and then get more information we are working on.
That's a consortium and an EU funded consortium. Is that correct?
Yes, they're based from the Horizon project, as you mentioned in the beginning, and we have another one also ongoing. We just got awarded a month ago from Cosmoport Horizon project that putting such a scanner to the mobile phone, because the many customs authorities they have these parcel centers due to e-commerce increase. And in every parcel center, they don't have the X-ray machines there. How to put it in the mobile way, or there are special events, or big concerts or whatever. So how to go there, and within the next 2 years, together with the customs authorities in Latvia, Estonia, Finland, Greece, UK, we are how to say developing this mobile scanner product based on the muon tomography. Exciting stuff. Could you talk a little bit about your fellow consortium members in Silent Border? Who else are you working with there? Silent Border, we have just opened the Tartu University from the local one. Then we've got let me be precise here. SGS as a technical partner, German Space Agency, University of Sheffield, and etc. Estonian University, Finnish and Turkish customs agencies. I see. Wow, that's a good team. I'll look forward to looking up. It was like a strong, how to say, phase when we got really like attention from the EU level, and then the first huge project. It's I think almost 8 million euros project. For the 4 or 5 years, and then yes, again by 2025, within next 2 years, we need to be ready with the first large container scanning gates or solution. Yeah. And that's your large Gscan module. Correct. 2025. Yeah. I see, and that's kind of your end point from the customs world is to develop a container scanner. Yeah, if we continue with the processes as we currently have, normally every customs station or border point has their own control hall or something. But with our technology, as I mentioned, you can use these detectors everywhere. You have to have this. Basically what we have on the roof there when border lines going there, you can build this roof also multifunctional. It's not like covering or helping with the rain, stopping the rain, but it can be operating as a scanner as well. So. I see. Well, I'm looking through the projects that Gscan is taking on, and we've already talked about nuclear waste in Soviet submarines. We've already talked about bridges across the UK. I'm reading. Well, obviously the customs applications from parcels and luggage to containers, but I'm also reading applications in the lunar and Martian environments. Is that correct? Yeah, that's like in the very beginning. We'll try to be also the like looking forward company, and then it's a small one, like how muons can be used and what kind of technology is there. But yeah, in the very beginning. But also what you just mentioned on what we also have the cooperation with the prison authorities. So the under this kind of vision that smart prison or smart detection, controlling the parcels for the prisoners or the perimeter there. So basically, recently we got just awarded by Estonian government, and we will give it first muon flux small scanner for the real testing with the one prison in Estonia. So it's like trying to how to say, do the first POC and then develop the product for the prison industry. What are the materials they want to check? What is the quantities? How much time you need for the measuring, and then etc. So happy to have this collaboration with the different countries and the governments that they are excited to how to say, to see what can be done beside the X-ray solutions.
So that's yeah. It's wonderful to see your the range of projects that you're tackling and the range of teammates that you're working with in order to tackle them. It's also very interesting to see your personal background and the range of experiences you brought to this work. As a customs official, is the Gscan technology something sort of like a dream come true? I mean, it sounds like it would be the ideal tool if it's perfected. Obviously, you need a lot more work to get it up and running, but it sounds like an extremely effective tool that customs across the world would benefit from.
I think it's following the global trends or technology trends like AI and machine learning. They basically nothing against with the X-ray solutions, but they are local one. They are more or less the manual one. They have like huge OPEX costs to keep these machines running. What else? I was in WCO last autumn, and then many countries were discussing in the big room that how to use the artificial intelligence in that technology. So basically, how to detect automatically. I don't know, is the gun, for example. So, and somebody said in that to put it in artificial intelligence from that technology, you need at least 60,000 similar picture of this gun thing, you know, and then you have this GDPR thing, that how to change these pictures, how to capture first the 60,000 people, and how to change these pictures between the countries to teach machine or learn machine that to detect it automatically. So I think that both technology will remain. You need X-ray with a fast shooting and then you get these images. But to make very sure that there is no explosive in a certain area, or I was told this cocaine bananas problem in European ports, there is no solution yet, because if even they see something like 105,000 tons of cocaine year before last year, it's peanuts, and then it means that there is no solution. There has to be some kind of step forward to the automation or some kind of machine or AI-based thing. So, and that's why they think that we are trying to change this paradigm, that it can be a solution.
Yeah, that's it. It really does sound like a paradigm shift technology. Am I right in saying that at this time it takes more time to produce not an image, but to scan something with muon scanner than it does with X-ray?
Yeah. It depends on the quantity also. That our technology is not very good at to find one tablet, one small track. But this is not the problem for the society. Problem is the tons or kilograms. So yes, if we raise this bar, a few kilograms already, it might take few minutes to scan, to gather the data. And few minutes is nothing compare if you want to move this container inside the border point to somewhere the control hall. So it will come, Tom, definitely. It will come if we are able to see that the accuracy is totally different level. So that's why we are doing these POCs with this prison authority and also with the Cosmoport program, that to measure that, to tell clearly to our potential client that, okay, if I want to seize 1 kilogram of cocaine, that's the measuring time, and that is the accuracy. So it's like, and then it might take couple of years to spread this understanding, but that's why I'm saying that people are they do the photo shoot with X-ray, but X-ray you need your own eyes to detect where it is. But in our technology, machine will tell you, is it there or not?
And the technological difference plus the fact that you're working in machine learning and AI platforms means that that's going to be a time saver. You're going to cut out human factor.
The material library. So we are not like detecting everything. We don't care about this and that goods. So we compare these 30, 50 top-notch critical materials in the world, and we teach our machine that okay, to detect these materials 50 in the library, you need that kind of measuring time, you need that kind of quantities, and then and after that it will be clear. We will guarantee that there is no human touch anymore, that the machine will catch the objects.
I see. Do you have regular interactions with customs administrations, universities, and external scientific research centers? It sounds like with your work with these consortia, you have regular interaction with these other areas.
Yeah, we partially grew up from the Tartu University, which is getting now 400 years old, by the way. So it's like I have 35 people in my team. 7 of them are PhDs, doctors, and 25 engineers. So basically, what we are now doing, building the business capabilities next to the R&D. We have done 6 years R&D. Heavy R&D behind that, so it's like it doesn't appear like from the scratch. So it's like this is our advantage that we are doing heavy work with the patent or IP protection. So we work together with the Finnish companies, and then we just recently got the first patent from Japanese market. So and then I think 5 to 7 still in the pipe. Protect the technology, and then how we are producing this, also the algorithms, because the half of the solution is the hardware and the half of this is the algorithms and the software and the machine learning. So both needs to be there. So and then that's why also these muons have been there a million years, but because of these capabilities of AI and machine learning, now it's doable. And they're working together with these universities, and also, as I mentioned, with the customs, with the Horizon project, with the prison authority. So engaging the clients already that what they want to see, to help them, because among my team there is no customs officers, there is no prison authority people. So we need some like deep knowledge expertise that what type of the machines we are developing, what is the product we are developing.
But it sounds like there is a customs officer or 20-year experience in customs at least.
Come on, Tom. I was like, I had like few months worked at the border, but in Estonian case, we just got independent, and then I have the customs background and also education. Very fast, I had to manage the people or leading the people, so I'm not very much hands-on with the custom controlling, but yeah, still knowing the people around and very much. If you are once in the customs family, you will stay there. So there is no one other in the country level. I've been in many other jobs also in the government sector, but I would say the customs family is the different, because this is the international family. You cannot compare with the police. You cannot compare with the tax people. Customs is very unique. If you once being there, you know people in the across the world, and then we all work together, and they are like brothers.
It sounds like a real, like you said, once you're in the customs family, you never leave. You're creating. Why is that? What is it about the customs environment that produces a sense of family?
It is because it's not the best things. We need to stick together. Customs people stick because as per my understanding, the taxation is domestic thing. Police is a domestic thing. Of course, they do the international cooperation and etc. But customs is not the domestic things. You are just dealing with the goods coming from somewhere, or you're sending goods somewhere, and you need to be very much engaged or talk to the different countries' customs officers. And that's why it's international. That's why the WCO is very strong. That's why I know different, international groups. And basically, I lived in Oman And the head of the customs in Oman was my best brother, because we used to do the same work. So we just met once and then shake the hands. Or any other countries. If I go there, I said I'm a previous customs head of the customs or customs officer. You are immediately brother.
What's next for Gscan? What are the new technological challenges you're planning to take on, and what customs tools are you aiming to provide to solve customs problems of the future?
Yeah, even it might sound strong, we are in the beginning of journey. So we got just ready with, as you mentioned, the muon detector infra solution we are now using already. And then we just month ago, we were ready with a small scanner. And then we start to do the first POCs, but things takes time, especially with deep tech or hardware. Right? It's people are used to ask that, does this machine do this and that? I said, come on, nobody has done it. I offer you to do it first in the world. Please join the journey. And then luckily I found many. They are attracted with this, and I'm very thankful for the competition or innovation award also to just spread the news that we are looking such a innovative minded leaders that who's not able to just ask does this machine do this and that, but will discover together with us that what are the opportunities. So, and as you mentioned that. There's like a lot of avenues. Still, we haven't opened yet, up to the medical, up to the this and that. So it's like I read the news that they want to use these muons for the GPS solutions. So people have discovered that there is a radiation, like safe radiation around us. How we can explore this? How we can use this like as a information transformers or whatever. So.
I see. And am I correct in saying that computer processing power has been one of the keys to opening the mysteries of the muon? Because before you couldn't do it in real time, whereas now you can make the calculations.
That measuring these two submarines in Estonia currently, we have captured many teras of data, terabytes. It's like huge data you are capturing, and now like how to set up all these like software solutions that to analyze this data. And this is like don't ask more. I'm not the engineer, so but I've seen that I need to pay the bills that if somebody wants to buy another supercomputer to handle this data.
Yeah, you see, you had to pull out the checkbook for the things the toys that the engineers want. I see. Well, with 7 PhDs and 25 engineers on your team, you probably do have to pull out that checkbook fairly often, don't you?
Yeah, but still, it also gives the trust that I can sell something based on what these guys are like developing. These PhDs are not salespersons. They are operating based on facts. And then this team, 7 PhDs, 25 engineers, they are giving to me or my business team this kind of like a certainty that it's doable. So like, and then we just need to create the conditions that these guys can continue to develop the product and the solutions.
Oh, that's exciting. It must be great to work with people who don't overpromise and don't oversell. They're just working on facts and on their technologies. And when they say it's ready, right?
Absolutely. And then they always asking more time. Let's do this and that. That's like, and it's a good how to say vibe in the company as well. That you need to have these business guys who like already using the mouth, saying something, and then I don't know, why not to say overselling, because that they need to be positive. But somehow the R&D and the engineers team, they have their own capabilities or deadlines or just physics behind.
Yeah. Well, it takes two kinds, right? It takes the imagination. It says, hey, we could use it for this. We could use it for that. We could use it for that. And then it takes the physicist realist who says, well, this is what we can do now. But the two kind of balance each other if you have the right balance in an organization.
One thing I learned, Tom, in the company within past year, 1 year, that there are always problems. And if your engineers coming to the meetings and say, no, Marek, this is something which we don't know. So I need to stay calm because these brains will figure it out. So just to need to give the time. But if they say no or they don't know yet, So I admire the science world that the human brain is there's no limits. There's no limits. Just you need some time and they will figure it out how to proceed.
Well, I know you have a lot of fans because I was sitting in the room with some very skeptical, very hard-nosed customs officials in Tirana in Albania who took the vote as to who was going to win the innovation prize. And I guarantee you it was a pretty skeptical audience. And if you convince them, it means that you have a lot going for you.
Thanks. I take it as a compliment. And there has to be people who are looking like thinking that there are always a chance or the possibility to do something. And then if you take this these current solutions as it is, they will not last too long. So you need to complement, you need to challenge these current technologies. And then I'm very happy that I have on that journey at the moment. And also, as you mentioned, that having this background that I have bought many X-ray scanners. But I would like to offer something which is a totally different story. And then this is my everyday life today.
Sounds like a great everyday life. Thank you so much, Marek, for joining me today and for talking about your fascinating and important work at Gscan and how it relates to the future of customs innovation. You're clearly making steps towards a new paradigm.
Thank you so much, Tom, and I appreciate your time, appreciate your effort to introduce us. And as I mentioned, that find me via LinkedIn or internet, and I'm happy to share more.
Terrific. I will make sure that your contact information is in the blog that goes along with this podcast, and we'll stay in touch. I hope to meet you soon.
Thanks a lot. See you in Estonia, Tom.
Yes, indeed. Thank you very much. Take care. You've been listening to Pushing the Envelope, Life at the Cutting Edge of Customs Innovation, a podcast that profiles leaders in customs and their views, ideas, and inspirations about the future of customs innovation. Join us soon for our next Pencast and another insightful conversation with customs trendsetters and forward thinkers.